That idea of conjugate pairs comes in handy whenever we're dividing. The whole point of dividing whenever we're dealing with complex numbers is to get the imaginary pieces out of the denominator. So to do that, I'll multiply by the conjugate because I know that will bring out the imaginary. My denominator in this case is 2 plus 4i. The conjugate of that is 2 minus 4i. But whatever I do to the denominator, I have to do the same thing to the numerator. So I'll multiply the numerator by 2 minus 4i. To multiply fractions, I multiply straight across. 1 times anything is just itself, so 1 times 2 minus 4i is just 2 minus 4i. And then if I distribute in the denominator, 2 times 2 is 4. So that was the 2 times 2. 2 times minus 4i is minus 8i. If I use a different color to show I'm distributing the 4i, I'll take 4i times 2, which is plus 8i, and then 4i times minus 4i, which is minus 16i squared. Clean this up a little bit. I have 2 minus 4i over. Remember that your imaginary pieces are going to cancel, so the negative 8i and the positive 8i cancel each other out, and I am left with 4 minus 16i squared. I squared is negative 1, so minus 16 times negative 1 is actually a plus 16, which altogether gives me 2 minus 4i over 20. I have to be careful about simplifying here. Every single term that I have in this problem, the 2, the negative 4i, and the 20, every one of them is divisible by 2. So I have to simplify this by dividing all of those terms by 2. So 2 divided by 2 is 1, minus 4i divided by 2 is 2i, and that is all going to be over 10, because 20 divided by 2 is 10. If you can divide all of your terms by the same number, then you have to do that. You have to make sure that you simplify by dividing all of those terms. The same process is going to be used for number 41. Let me sort of block off a section here. So I'm going to multiply by the conjugate of the denominator. I have to bring those terms out of the denominator. The denominator is 1 plus 2i. The conjugate is 1 minus 2i. In the numerator, I have 4 plus 3i. It's tempting to want to multiply by the conjugate of the numerator, but remember, I'm not changing the value of the fraction I'm starting with. And the only way I cannot change the value is if I do the exact same thing to the numerator and denominator. Since I multiplied the denominator by 1 minus 2i, I'm going to multiply the numerator by 1 minus 2i. Both of them get multiplied by the same thing. When I go to distribute in the numerator, I'll take that 4 and multiply it by each term. So 4 times 1 is 4, and 4 times minus 2i is minus 8i. Then I'll take that 3i and distribute it to each term inside that second set of parentheses. So 3i times 1 is plus 3i. 3i times minus 2i is minus 6i squared. All of that is over what I get when I multiply the denominator out. If I take the 1 and multiply it by the 1 and the minus 2i, 1 times 1 is 1, 1 times minus 2i is minus 2i, and then I will do the same thing with the 2i. I'll take 2i times 1 and 2i times minus 2i. 2i times 1 is plus 2i. 2i times minus 2i is minus 4i squared. If I clean all this up a little bit, let's see, I have in the numerator 4 minus 8i plus 3i is minus 5i, and then this I squared is equal to negative 1, so that's minus 6 times negative 1, which is the same as plus 6. In the denominator, my minus 2i and plus 2i cancel each other out, so I have this 1, and then I have minus 4i squared, but again, I squared is negative 1, so this is like minus 4 times negative 1, which is plus 4. In the numerator, I have the 4 and the positive 6, which is 10. I have the minus 5i. That will all be over 1 plus 4, which is 5. And then just like before, all three of these terms can be divided by the same number. They can all be divided by 5. So 10 divided by 5 is 2, minus 5i divided by 5 is I, or 1i, all over 1. You have to simplify if you can divide all your terms by the same number. So this one ends up being 2 minus I over 1. You can put the 1 in the denominator or you don't have to. Either one would be correct. Okay, another division problem where I have to make sure that I multiply by the conjugate of the denominator. Both the numerator and denominator get multiplied by that conjugate. The conjugate of 2 plus I is 2 minus I. So that 2 minus I goes in both the numerator and the denominator. In the numerator, I'll distribute the 7 to each term. So that gives me 7 times 2, which is 14. 7 times minus I is minus 7i. I'll follow that by distributing the I to each term. So the I times 2 and the I times minus I. I times 2 is plus 2i, and I times minus I is minus I squared. All of that is going to be over what I get in the denominator when I multiply. I'll take 2 times 2 and 2 times minus I. 2 times 2 is 4. 2 times minus I is minus 2i. And then finally, take the I and multiply it by each one of those terms. I times 2 is plus 2i, and I times minus I is minus I squared. If I start to clean this up, I have the 14 in the numerator. Minus 7i plus 2i is minus 5i. And then minus I squared. I squared is negative 1, so minus a negative 1 is the same as plus 1. All over, my negative 2i and plus 2i cancel each other out, so I have that 4. Minus I squared is the same as minus a negative 1. That's the same as plus 1. Put this together, I have the 14 plus 1 is 15, minus 5i. That's all over 4 plus 1, which is 5. And just like what was discussed with the last problems, every one of these terms can be divided by 5. So 15 divided by 5 is 3, minus 5i divided by 5 is I, all over 5 divided by 5, which is 1. So your answer is 3 minus I over 1. Again, it's fine if you were to just write that as 3 minus I. You don't need that 1 in the denominator, but either way is fine. For these ones, we're asked to convert the imaginary numbers to standard form, perform the indicated operation, and express the answers in standard form. Well, the imaginary numbers here would be the square roots of the negatives. And to take the square root of a negative, you're basically just taking the square root of the number as if it were positive, and then being sure to include the I to indicate that it was a negative. So for this first number, the 2 minus the square root of negative 4, the 2 stays a 2, minus the square root of negative 4. Well, the square root of 4, square root of positive 4 is 2, so the square root of negative 4 is 2i. So I can rewrite this number as 2 minus 2i. Same thing with the second one. 5 minus, the square root of positive 9 is 3, so the square root of negative 9 is 3i. So this is just 5 minus 3i. I'm adding two complex numbers together, so I just need to add the real numbers together, and then I need to add the imaginary numbers together. If I do that, 2 plus 5 is 7, and then negative 2i plus negative 3i is minus 5i. So my answer is 7 minus 5i. With the next one, same idea. I just want to rewrite this using those imaginaries, simplifying those imaginaries. I have the 9 minus. The square root of 9 is 3, so the square root of negative 9 is 3i. Minus 12 minus the square root of negative 25. Well, 12 is 12. Minus the square root of positive 25 is positive 5, so the square root of negative 25 is just 5i. If I simplify, I have 9 minus 12, which is negative 3, and then I have to remember to subtract everything, so I have negative 3i minus negative 5i. Well, minus a negative is the same as adding. So I have negative 3i plus 5i, which is plus 2i. And that is my answer. Finally, same idea. If I rewrite this, I have 3 minus, the square root of 4 is 2, so the square root of negative 4 is 2i. And I'm multiplying that by negative 2 plus the square root of positive 49 is 7, so the square root of negative 49 is 7i. I'm multiplying, so I need to distribute. I'll distribute the 3 to each term inside the second set of parentheses. 3 times negative 2 is negative 6, and 3 times 7i is plus 21i. Then I will distribute the negative 2i to each term inside the second set of parentheses. Negative 2i times negative 2 is positive 4i, and negative 2i times positive 7i is minus 14i squared. Clean this up a little bit. I have the negative 6 plus 21i plus 4i is plus 5i. And then minus 14i squared, I squared is the same as negative 1, so that's minus 14 times negative 1, which is the same as plus 14. Negative 6 plus 14 is 8, and I still have the plus 5i.